Imagine piloting 73,000 pounds of steel down a mountain, and your brake pedal suddenly turns into a solid brick. In 1955, the founder of Cummins pitched a life-saving solution, but his own board rejected him. So, he hijacked the engine's soul with a drill chuck maker. They turned the motor into a massive air compressor with a deafening 105 decibel machine gun roar. It saved lives, but it triggered a brutal corporate bloodbath and forced towns everywhere to ban the noise. But the craziest part? That outlawed 1950s tech is the stealthy secret saving modern zero-emissions diesels today. This is how the highway's loudest outlaw became its quietest savior. Clessie Cummins birthed the American diesel industry, but by 1955 the boardroom at Cummins Engine was overrun with suits and spreadsheets. The man whose name was on the building was gone, forced into retirement after years of fighting the brass. Most guys would take the pension and go fishing. Not Clessie. He and his son Lyle retreated to a sprawling basement machine shop and a 4-car garage out in Sausalito, California. They spun up a skunkworks project the corporate world called a waste of time. While the suits chased profit margins, a nightmare from Clessie's past kept him up at night. He knew the trucking industry had a massive, hidden body count. Heavy-duty trucks in the 50s had a fatal flaw. Lift off the gas in a regular car and it slows down. The throttle plate closes, pulling a vacuum that drags the pistons back. The engine chokes. A diesel engine doesn't do that. It breathes wide open air all the time. Let off the pedal in a 1955 rig and the engine kept spinning freely. Zero natural braking. The only thing keeping over 73,000 pounds of loaded steel from hurtling off a mountain was a set of friction drum brakes. The physics were terrifying. Hauling down a mountain grade meant drivers lived on the brake pedal. Those drums hit 500 degrees Fahrenheit in minutes. At that heat, the brake pads literally boiled, trapping a layer of slick pressurized gas between the shoe and the drum. Brakes fade. The pedal turned into a solid brick with zero stopping power. Imagine trying to stop a train by rubbing 2 wet bars of soap together. Runaway trucks became unguided missiles, smashing through anything in their path. Clessie knew this crisis firsthand. Back in 1931, Clessie was pushing an Indiana truck on a brutal coast-to-coast endurance run. Dropping down that 3,777-foot grade at Cajon Pass, his brakes cooked and he barely missed a freight train. That near miss turned into a lifelong obsession. To fix it, Clessie and Lyle got to work. They took a GMC Suburban, sawed it in half, and stretched the frame, front clip and hood exactly 12 inches. They needed the room to drop in a 125-horsepower JN6 diesel, beefing up the front suspension to handle over 1,500 pounds of dead cast iron weight. They took this Frankenstein rig out to San Francisco, bombing down the steepest streets to test their makeshift hydraulic setup. It worked. Clessie dragged the prototype back to the company he founded, walking into the boardroom with a proven way to stop the carnage. The directors blinked. They claimed the market didn't want a complex braking system. They rejected the man whose name was cast on their own engine blocks. That should have been the end of it. But in a lonely Phoenix hotel room in 1957, unable to sleep, Clessie had a breakthrough. He grabbed a notepad. The problem wasn't the brakes outside the engine, it was the air inside. A diesel compresses air, fires fuel, and makes power. But what if you changed the timing? What if you hijacked the exhaust valves to blow off that compressed air right at the top of the stroke, before it pushed the piston back down? He sketched out a way to turn the engine into a giant air compressor, bleed the cylinder pressure off just before top dead center, and the engine fights the wheels instead of driving them, spitting out that legendary window-rattling bark we all know. He figured out how to use a slave piston to transfer the pushrod motion from the injector cam straight over to the exhaust valve, a simple hydraulic link turning the engine itself into a brake. No friction pads needed. It was the answer to a 20-year crisis. But with Cummins Engine Company slamming the door in his face, Clessie needed a partner. To build this blueprint, he'd have to forge an alliance with a company that knew absolutely zero about heavy trucks. By 1959, Clessie found that unlikely ally, the Jacobs Manufacturing Company. They were the undisputed king of drill chucks, those high-precision steel grips locking drill bits dead center. But with a saturated market, they desperately needed to put their machining chops into something new. Taking a massive gamble, they saw the raw potential in Clessie's weird engine brake. Jacobs used their precision chops to design a hydraulic circuit that tapped straight into the engine's own pressurized motor oil, turning it into the muscle that forced those exhaust valves open. For a tool company to pivot into heavy diesel was a massive gamble. The learning curve was a vertical climb. To prove the rig actually worked, they set up a brutal test with Sheldon Oil. They handed the keys to Bill Hill, an 18-year veteran hauling 400-degree Fahrenheit liquid asphalt down US 50 near Lake Tahoe. They popped the hood on Bill's rig and bolted that first crude prototype straight onto the rockers of a legendary Cummins NH220. That descent is a brake killer. Normally, Bill's drums would get so searing hot he'd blow right past his turnoff, hunting flat ground just to stop the rig. But with Clessie's prototype bolted on, the results hit hard. On that same grade, Bill touched his service brakes exactly twice. When he pulled over, the heavy iron drums weren't smoking, they weren't glowing, they were cool to the touch. This wasn't just taking the edge off. That prototype was suddenly pulling nearly 175 braking horsepower out of thin air, completely taking the load off the wheel ends. Still, the price tag was a massive hurdle, $800. In today's money, that's north of $8,000. Fleet owners thought the team was crazy. To sell it, Clessie's brother DeLoss and Jacobs executive Paige Waddell spent 5 grueling weeks in the summer of 1960 pounding the pavement across the country. They boxed up that first production run, stamped it as the Model 20, and hit the road. Their pitch was simple. This device pays for itself in under a year because you stop burning through ruined brake drums. While the suit struggled to sell the math, the drivers took over the marketing. The official name, Jacobs Engine Brake, was too clunky for the CB radio. Truckers cut the syllables. Over the static, they called it the Jake Brake. The nickname spread like wildfire. By 1972, it was so deeply ingrained in trucking culture that Jacobs surrendered and trademarked Jake Brake just to stop it from becoming a generic term for every engine brake out there. Behind the scenes, massive military contracts turned the business into a powerhouse. Jacobs started outfitting 40,000-pound tactical rigs built for war zones. We're talking about outfitting absolute beasts like the M54 5-ton cargo trucks headed straight for the mud in Vietnam. These heavy armored beasts could now bomb down steep hills without their brakes outgassing and failing under fire. That government cash built a quiet empire. It funded the R&D that turned a basement invention into an industry standard. But the Jake Brake wasn't just a safety feature. It was a mechanical masterpiece that changed the sound of the American highway. To understand why this iron became a legend, we have to look past the contracts. We have to look inside the engine block. We need to see the violent physics generating that world-shaking machine gun roar. This wasn't a clever upgrade. It was a complete hijacking of the engine's soul. Forget the sales pitches. Look at the iron heart of the engine. The original Model 20 Jake was bolted straight onto the legendary Cummins NH220. It was the perfect marriage of raw power and rebel engineering. Clessie's invention didn't just add a part, it hijacked the engine's internal timing with a hydraulic lost motion circuit. U.S. patent 3,220,392 uses the engine's own lubricating oil to bridge a mechanical gap. It taps the camshaft's third cam, the one normally triggering fuel injection. A master piston rides the injector cam, squeezing hot pressurized oil into a slave piston right above the exhaust valve. It forces that valve open at exactly the wrong time for the engine, but the perfect time for the driver. In a normal diesel cycle, the piston moves up, compresses air, and fuel injects for the power stroke. Clessie's system rewrites the rules. Just before the piston hits the dead top of its compression stroke, a hydraulic slave piston slams that exhaust valve open. That highly compressed air was about to act like a massive spring to push the truck forward. Instead, it dumps straight into the exhaust manifold. The engine stops making power. It becomes a massive, power-absorbing air compressor fighting the momentum of the drive wheels. A properly dialed-in Jake can actually rip out up to 600 horsepower of braking force, sometimes pulling harder than the engine makes on the throttle. And the driver controls the chaos right from the dash, flipping toggle switches to drop the hammer on 2, 4, or all 6 cylinders depending on how heavy they're hauling. Because it runs on oil pressure, when you flip that switch, there's a split-second delay while the gallery's packed full of fluid. And then, bam, the engine starts barking. But you'd better watch your tachometer. Let the RPMs climb too high on a steep drop with the Jake howling, and you'll float a valve right into a piston, turning that iron block into a grenade. This internal tug-of-war creates that signature machine gun bark echoing off canyon walls. People think that sound is a series of small explosions. It's not. It's a phenomenon called choked flow. When that slave piston cracks the valve, air pressurized at over 500 psi rushes out at Mach 1. This creates a rapid-fire string of miniature sonic booms as the air violently expands into the manifold. It's raw physics, screaming out the exhaust stacks. This tech made extreme trucking routes possible. Take the Australian road train. These 400,000-pound behemoths are locomotives on tires pulling multiple trailers across the scorching outback. On long, unpaved dirt descents, traditional friction brakes would vanish in a cloud of choking dust and smoke in minutes. But with a Jake brake, these massive rigs hold steep grades with zero thermal fade. The intense heat from compressing all that air gets absorbed by the engine's cooling jacket and blasted out the exhaust, keeping the wheel brakes ice cold and ready for emergencies. By the 1970s, the Jacobs engine brake went from a desperate invention to an industry standard. It didn't just save drivers from going over the edge, it saved them thousands of dollars in smoked brake drums and glazed shoes. During the golden age of the independent trucker, that 500 psi stutter echoing from the dual chrome stacks of a Peterbilt wasn't just a safety feature, it was a declaration of power. But the very sound giving drivers confidence was driving the rest of the country crazy. The inventor's legacy was about to face its toughest test. By the 70s and 80s, that 500 psi stutter was everywhere. It was the anthem of the American road. Every Peterbilt and Kenworth had one, and Jacobs held a total monopoly. Competitors tried to break in. Mack trucks engineered their own system, the Dynatard, to dodge royalties. It was fully integrated right into the factory valve train, shifted camshaft timing to drag the engine, but it couldn't match the brutal 500 psi holdback power of a genuine Jake. Depending on the rig, a genuine Jake could turn a 400 horsepower diesel into a 350 horsepower air compressor, giving operators massive holdback power on a steep grade. But that deafening machine gun roar had a price. As the noise spilled from mountain passes into quiet towns, public backlash triggered a culture war. The EPA stepped in with the 1972 Noise Control Act. An unmuffled Jake barking down a mountain was easily pushing 105 decibels. The feds wanted to choke that down to a strict 80 decibels at 50 feet, threatening a flat-out ban. Jacobs didn't just sit back. They quietly partnered up with the heavy hitters at Donaldson to engineer high-flow mufflers that would satisfy the feds and keep the trucks rolling. At the same time, Jacobs launched a signage war. Towns were throwing up no Jake braking signs everywhere, and Jacobs sued them. They were terrified of genericide, losing their trademark because the name became too common, just like aspirin. Under threat of a lawsuit, they forced local governments to strip the brand name off the steel and switch to generic phrases like no compression braking. While Jacobs fought regulators, a bigger threat brewed out in the Pacific Northwest timberlands. Pack Brake, one of Jacobs' best distributors, started making simple exhaust brakes. They were basically just heavy-duty butterfly valves bolted right behind the turbo, choking the downpipe to stack up exhaust back pressure. It was a cheap alternative that Jacobs ignored. But Pack Brake wasn't going to stay a quiet distributor forever. They were studying the iron, waiting for their moment to strike. The 1980s kicked off what truckers called the Clone Wars. While Jacobs fought small-town noise ordinances, a massive threat grew in their backyard. Up in the Pacific Northwest, Pack Brake had spent years as a top Jacobs distributor. It's brutal country. Wrenching on massive logging rigs for outfits like Hayes and Pacific, Pack Brake learned exactly what it takes to keep a 250,000-pound off-highway load from careening off a mountain. They mastered the high-pressure hydraulics and the exact metallurgy needed to keep those housings from cracking under extreme thermal cycles. They didn't just fix parts, they studied them. Pack Brake engineer Vincent Manili saw the industry shifting. Jacobs owned the traditional setup, but Caterpillar's new 14.6-liter 3406 engine threw a wrench in the gears. Jacobs engineers couldn't squeeze maximum retarding power out of it without risking bent push rods or snapping the valve bridges. Manili saw an opening. He delayed the engine brake timing just a fraction of a second, letting it work alongside a traditional exhaust brake, a simple butterfly valve building up to 60 psi of back pressure right in the pipe. Combining the two created what they called the combination brake. It hissed, it grabbed, and it completely outbraked Jacobs on the big cats. The student became the master. The real powder keg went off in 1982 when Clessie Cummins' core patents expired. Pack Brake pounced. They started machining direct drop-in replacement parts for Jacobs hardware, like the P-30 housing built specifically for the legendary 855 cubic inch Cummins. They reverse-engineered the crown jewels of the industry. Overnight, a trusted partner became a deadly rival. It wasn't a business pivot, it was a declaration of war. That triggered a brutal, decade-long legal bloodbath. It cost millions. It wasn't just about cash, it was a bare-knuckle fight over who owned the soul of the diesel engine. Jacobs fought for their legacy, Pack Brake fought to compete, and all that courtroom fighting just proved the sheer value of Clessie's original basement invention. When the legal dust settled in the early 90s, Clessie Cummins had been dead for over 20 years, but his engine brake was a global standard. You have to wonder what the brass at Cummins thought, watching rival outfits get rich off the exact idea they threw in the trash decades earlier. They ignored a mechanical revolution. Now they were paying for that arrogance. The story doesn't just stop there. Cummins finally ate crow and bought Jacobs in 2022 for $325 million. And just like that, the drill chuck company that beat them at their own game finally cashed out. It was the ultimate corporate surrender. After 60 years, the intellectual rights to that 1965 patent are finally back home at Cummins. And Clessie's original basement lathe, the heavy iron he used to turn out the prototype they originally rejected, now sits proudly on display at the Cummins Heritage Center in Columbus, Indiana. You'd think this loud, hammering 1950s tech would be dead in the age of zero emissions. It's actually the opposite. Modern diesels face a thermal paradox. To meet strict standards, their selective catalytic reduction systems have to stay above 392 degrees Fahrenheit to light off and scrub the exhaust. When a rig is just idling or coasting downhill, the exhaust pipe runs cold. The chemistry stalls, and the engine fails its smog test. Enter a modern engineering lifesaver, cylinder deactivation or CDA. Instead of using the hydraulic circuit to violently blow off pressure and create that signature barking roar, engineers now use it for cylinder deactivation. They lock the valves shut on dead cylinders, turning those pistons into heavy dead air springs. The firing cylinders have to lug harder just to drag that dead weight. That heavy load generates intense exhaust heat, keeping the aftertreatment baking hot without burning extra diesel. At high idle, flipping Clessie's tech on its head saves up to 18% in fuel. That old outlaw roar, the one that forced towns across America to bolt up no engine brakes signs, is now a precision tool for the modern X15 engine. It's the ultimate mechanical irony. A desperate fix to keep a runaway rig from smoking its drum brakes down a mountain is now the backbone of modern emissions control. Clessie didn't just invent a brake, he hammered out a heavy legacy that refused to be silenced, even when his own company tried to pull the plug. It's a sweet payback for a guy once locked out of his own shop. So, do you still call every engine brake a Jake brake? Or were you at the wheel when the town started swapping their signs? Drop your answers in the comments below. If you respect the iron and the renegades who built it, hit subscribe for more untold stories of heavy engineering. Leave a like if you learned something new, and I'll see you in the next one.